Mr. Eric, Mr. Ryan, alright? Yeah? Okay, so we talk about a graph problem today. Graph. What's graph? G. Yeah? What's graph? What does it have? How do we represent a graph? What do we have for graph?
Tree.
No. What I'm saying is the graph is
Vertex.
vertex and edges. Yeah, it's a collection of vertex and edges. So let's use the vertex like look 0, 1, and then 2. Here, look, this is a graph. Yeah? 3 is also a graph. So look, if the graph doesn't have these arrows, yeah, it doesn't have arrows. We call it what? We call it what graph? If it has arrows, we call it directional graph. Yeah, remember? Directional graph. You still remember DAG? Yeah, what's DAG?
Directional acyclic graph.
Acyclic. What's acyclic mean?
It doesn't go like around and round, you know.
It doesn't have. It's not like that. Right? If it's a graph, it's that 0, 1, 2, 0 to 1, 1 to 2, 2 to 1, and it forms a cycle. That's a cycle. But a cycle doesn't have something like that. Okay, a cycle. So today we talk about this graph, which is unidirectional, which means it's bidirectional. You can do it as bidirectional. 0 is let's say it's 0 is connected to 1. 1 is also connected to 0. So let's say a friend. Okay, friend 0 is has a friend 1. Yeah, the mutual. If I'm friend with you, you are also my friend, right? You are my friend and I'm your friend, right? 0 is friend of 1. 1 is also friend of 0. 1 is friend of 2. 2 is friend of 1. So can you tell me in these 3 people, at least for each people, at least one friend, right? Yeah, is it true or false? This statement. Everybody has at least one friend in this graph.
Yeah.
Yeah. Okay. And how about it? 0 to 1, and 2. Everybody having at least one friend?
No.
No. Which one doesn't have at least one? 2. Yeah, obviously. Okay. So, what's your thoughts? I mean, remember a few days ago we talked about a data structure. What is it called?
Disjoint set.
Disjoint set. Yeah, disjoint set. So what can we do with the disjoint set? What can we do with the disjoint set? Remember, we use the disjoint set to do what? To solve this problem, to finding if there's a path between a source to the target, right? So look, 0, 1, 2, and then 3, 4. We want to find out if there's a path, remember, from 0 to 4, right? So we create a disjoint set, and every time there is an edge, what do? We merge 0 and 1 into one group, right, Eric? And then there's an edge between 1 to 2. We merge it, yeah? And if there's a path between 3 to 4, we merge it, right? We merge it into one group. And at last, we check if the source and the target belongs to the same group, right? Belongs to the same group. If it belongs to the same group, what does it mean? It means that there's a path between the source to the target. Otherwise, it's not possible, right? Because disconnected. Look, there's no path between 0 to 4, right? Because it's disconnected. So can we use this disjoint set to solve this problem? It's quite similar, but there's something very slightly different. So Eric, look. So what's your thought? Can we use the disjoint set? So for disjoint set, we can merge. We can merge 2 vertex. We can check if 2 vertex belongs to the same group, right? Yeah. And we can check if the connected group, the group count, the number of groups, yeah, the number of groups. We can get this and what else, yeah? Yeah, we can find a parent. Find a group number find which group it belongs to, alright? So can we use these 4 to solve this problem? Any idea? What's your thoughts? What's your thinking? How do we find out if everybody has at least one friend? At least one friend, right? So at least one friend, we can think about at least one edge, yeah? Okay? So what's your thought? Any idea?
I think it's something. I'm not sure.
Don't worry, just think about just talk aloud. What's your thoughts? Any thoughts? How are we solving this?
I don't have any thoughts.
You don't have any thoughts. So can we use these disjoint sets?
Yeah,
We
but
can use
no.
Yeah.
Yeah.
If you don't have any thoughts, what's the first thing you need to check? start with B. B R. What?
Brute forcing.
Yeah, brute forcing. How do we brute forcing? The question is to ask if everybody has at least one friend. So we just need to go through everybody, right?
Oh yeah.
And then check if it has one friend, right?
Oh yeah.
So how do we check if it has one friend? So if we process this graph into a hash set, right? We can just use the hash set. To store these, what key is the, remember key is the vertex, and the value is a list of edges it points to, right? Edges it points to. List of vertex, okay? Vertex is connected to. So if we preprocess these edges into this adjacent linked list, we call it adjacent linked list. Then we check, we go through each vertex, right, Barry? And then check what? And then check if the list, the size is more than 1, right? If it's not more than 1, if it's 0, what does it mean? It doesn't have any connection to other people, right? Right? Yeah? So remember, if you give them this 0 to 1, you need to also preprocess this 1 to 0, okay? And then you go through each one, and then let's see. The time complexity is what? If there are n vertex, what's the time complexity? What's the time complexity?
N square.
On is going through each vertex, but how do we check if there's a connection or not? We just need to check the length of yeah, this is O1. So On times O1 equals what? Yeah, On. Okay, that's one solution. Yeah, brute forcing. It's good enough. Yeah, but we talk about using this disjoint set. How do we check it? If we
Is that it's fine with ON?
yeah, it's fine, but yeah, here is more solutions there. So disjoint set, we create the disjoint set, we merge it, yeah, we merge it like that, right? But look, we are not checking this group, right? We are not checking the same group, right? We are not checking look, this is 2 group, right? Yeah? But how about this? This 2 group, you need to tell me it's true, it's false, because 2 doesn't have any friend. How about this? 0 to 1, and then 1 to 2, 2 to 3. You see? Still 2 groups, but at least everybody has at least one friend. You see, right? Got it?
Yeah.
So this is irrelevant to the group, right? Number of groups. So how can we do this?
Merge.
No. We need to find out the parent, the group. So if we find all the groups for each vertex, and then look, how many groups does it belong to? 2, right? 2. Look, this is 1. If this group 1, group A, right? A, B, B. Okay, so what does it mean? So you see the group number needs to be at least 2, right? And how about this? If it is a 4 here, and then this is group C. C only appears once, right? So if we can do this, we can put it in the counter, right? And then we just check the values. The key is the group number. The value is the number of vertex it belongs to, right? If the value is 1, what does it mean? If the value is 1, what does it mean? There is only one friend. There's a friend which doesn't have any friend, right?
Yeah.
That's why the group number is 1, because there is no other friend who shares the same group. Okay, so let's do this. It should be very easy, right? Let's say define check. Okay, let's just call it function foo. Let's just call it G. Maybe edges. Okay, so the disjoint set, du equals disjoint set. Disjoint. This is the value. Disjoint set ds. Disjoint set, and there's n, right? We put it n. Okay, and then we do this what? For a, b in ds. A is a friend of B, so we do this ds dot what? Which function is it? Come on, we want to merge. Merge A and B, right? So now we got this. Look, Eric, 0 to 1. Look at me. 2 and 3.
I can't.
Come on, turn around, please.
Yikes.
Look, 0 to 1, 1, 2 to 3. There are two groups, right? But we want to find out the group number and put it in the counter, right? So look what? Let's say G equals counter what? DS dot group, find group, okay? Let's know find group I, right? This is the find group for each one, and for I in what? In range n, right? In range n, that's it. Okay, so now I just need to check return minimum G dot values. What? G dot value dot what? Come on. G dot value is the number of vertex that have the same group. So if you're saying that at least everybody has at least one friend, so what's this? The minimum, the G dot value needs to be what?
At least 2.
At least 2, so it's bigger than 1, or at least 2 bigger. Yeah, well done. Okay. Yeah, you see, this is the way we're using the disjoint set to solve this problem. But we can do it better, right? Because look, 0 to is the friend of 1, and so these two cannot be the answer, right? Cannot be the friend who doesn't have any friend, right? Got it? So what we can allocate a Boolean array.
A Boolean?
Boolean, what's Boolean? Can you tell me Boolean? We talked about this before. It has two values, Boolean. T and F, what's this? Come on. What's this?
Oh, true or false.
True or false, Boolean, that's what it means. Binary, true or, yeah, it's binary, yeah, binary. So we have a Boolean variable. At the beginning, they all initialize to false. Right? And then if you look, 0 is a friend of 1. So what do? We set that 0 to true. We set that 1 to true. If 2 is a friend of 3, what do?
It says
To true. And then to true, yeah? Then we just need to check this array to see if it has a false. Right? Okay? Yeah? Okay, let's do this.
But how do you know how much
N.
notes?
Sorry,
How much those people are they?
There are n people. Look at given n people. Okay?
Mm.
Okay, so look. Let's say just what do we call? We call it data, okay? Data equals false times n. What does it mean? False times n. Sorry? Come on, times, multiple. If the value multiple n times, what does it mean? There's a list which
With all false.
with all false. How many false are there? N, easy, yeah. Look at 1 times 3. What does it become? 1, 1, 1, right? Yeah? Yeah? Easy, yeah? Okay, so and how about this? A, B, C times 2. What do we get?
A, B, C, A, B,
A, B, C, well done. Yeah, you see? This multiple is very powerful, okay? So we have this false, and then what do? For A, B in edges, yeah?
Ow.
And then what should we do? This A is friend with B, so what should we do? Data what? Data.
Dot.
Data what? Data is an array. Data dot what? Huh? Data what? A is a friend of B. Look, A is a friend of B at the beginning. False. Remember we talked about.
A.
Yeah, A equals
True.
2. Okay. Data B equals what?
True.
Okay, so actually you can write it is one line. Look, you can write this one. Data A equals data B equals true, right? Okay, so now we have an array with this very. Okay, so how can we check easily what if there's true values in here? How do we check if there's only one kind of value here? How do we check?
What do you mean?
So how do we check if there's okay, so how do we check if there's a true there's a false in there? So look, if everybody is true, right? So we want to check if there's a false here. So one way is that for I in data if not I, if I, right? If not I, return false, right? Return false. Otherwise, return true. Yeah, this is what easy way. Yeah, you go through each values in the data and then check if it's false. If it's false, if it's still false, then we return true. Return false, right? Otherwise, return true, right? Yeah. We want to find out that what's it mean. It means true. It means true. When it's true, it means that all the values in data is true, right? So how about we can do this here? We can just say return data. Look, we can use this data.count false. We need to say count false equal 0. Okay. So what does it mean? You will go through the data to check to count how many values are equal to false, right? And this value needs to be 0, right? Got it? What's the time complexity?
O-N.
What's the space complexity? What's the space complexity?
Ow.
What's the space complexity? Come on, are we using any space here? Are we using any space here?
No. Yeah.
What's this?
O-N.
Okay, okay, so here,
Come on.
come on. Data.count what?
I just remember.
You can remember, it's easy.
I don't know.
Data is the list. We want to count what? We want to count what?
We want to count that.
Huh?
We want to count that.
Oh.
Count false equals what?
Equals 0.
Yeah, because there should be no count. Should be lowercase. Okay.
It took 1 millisecond.
Yeah, count should be lowercase. Okay, because
How
okay,
could the computer take 1 millisecond?
because the computer is really fast. Okay, that's it for today. Good job. Good job. Say bye bye to people.
Bye bye.
Bye bye.
Bye bye.